Hello students, I am Dr. Satish Chauhan, your chemistry teacher. I welcome you all in the video lecture series number 5. In this video, we will learn molecular orbital energy level diagrams for homonuclear diatomic molecules of second row elements. Let us, let us begin our story. In the second row of periodic table of element contains lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon elements. Lithium and beryllium contains 1s and 2s atomic orbitals, while boron, carbon, nitrogen, oxygen, fluorine and neon element contains 1s, 2s and 2p atomic orbitals in their atom. The overlap of 2s and 2s orbital gives sigma 2s and sigma star 2s molecular orbitals. The overlap of 2px and 2px orbital gives sigma 2px and sigma star 2px molecular orbitals. The overlap of 2py and 2py orbital gives pi 2py and pi star 2py molecular orbitals. Similarly, the overlap of 2pz and 2pz orbitals give pi 2pz and pi star 2pz molecular orbitals. The pi 2py and pi 2pz molecular orbitals and similarly the pi star 2py and pi star 2pz molecular orbitals have equivalent energies, hence they are said to be degenerate molecular orbitals. The magnitude of the overlap decreases in the order S sigma is equal to P sigma greater than P pi P pi. Hence, the value of delta or beta also decreases or increases in the same manner. The electron configuration of molecular orbitals can be given as sigma 1s less than sigma star 1s less than sigma 2px less than pi 2py is equal to pi 2pz less than pi star 2py is equal to pi star 2pz less than sigma star 2pz. Let us consider molecular orbital energy level diagram for oxygen, fluorine and neon molecules. Let us consider this is an energy axis. Let us consider this is the 2s orbital of first atom and 2p orbital. Let us consider this is the 2s orbital and 2p orbital of the second atom. When 2s orbital of first atom and 2s orbital of the second atom combine together, they form two molecular orbitals, that is sigma 2s and sigma star 2s antibonding molecular orbital. Similarly, when 2px orbital of the first atom and 2px orbital of the second atom combine together, they give rise to the sigma 2px molecular orbital, bonding molecular orbital and sigma star 2px antibonding molecular orbital. Similarly, 2py and 2pz orbitals of the first element combined with 2py and 2pz atomic orbitals, giving rise to the two bonding molecular orbitals and two anti-bonding molecular orbitals, namely pi 2py and pi 2pz and pi star 2py and pi star 2pz molecular orbitals. So electronic configuration of this system can be generally explained as sigma 1s less than sigma star 1s less than sigma 2px less than pi 2py less than pi 2pz less than pi star 2py is equal to pi star 2pz less than sigma star 2pz. So here pi 2py and pi 2pz have the equal value, that means these are degenerate orbitals. Similarly, pi star 2py is equal to pi star 2pz, therefore these are degenerate orbitals. The energy of these orbitals is same. The above diagram and the sequence of energy level assumes that the 2s atomic orbital overlap with only 2s atomic orbital and 2p atomic orbital overlap with only 2p atomic orbital. That is, there is no interaction between 2s and 2p orbitals of given atom. In Li2, Be2, C2, B2 and N2, the energy difference between 2s and 2p atomic orbitals is not large, and they are likely to interact when they have the permitted symmetry. Consequently, 2s and 2px atomic orbitals interact with one another, resulting in the repulsion between pair of orbitals of the same type, that is sigma 2s and sigma 2px and 2 sigma star orbitals, that is sigma star 2s and sigma star 2px. The new sequence of molecular orbitals for Li2, Be2, B2, C2 and N2 thus becomes sigma 1s less than sigma star 1s less than sigma 2s less than sigma star 2s less than pi 2py is equal to pi 2pz less than sigma 2px less than pi star 2py is equal to pi star 2pz less than sigma star 2px. After nitrogen, the energy difference between the 2s and 2p atomic orbitals becomes sufficiently large, and such effect may be practically neglected. Let us consider the molecular orbital energy level diagram for B2, C2 and N2 molecules. This is an energy axis. Let us consider the 2s and 2p atomic orbitals of first atom. These are the 2s and 2p orbitals of the second atom. When 2s and 2s combine together, they will give rise to the two molecular orbitals, that is bonding molecular orbital sigma 2s and anti-bonding molecular orbital sigma star 2s. Similarly, we can have the pi 2py and pi 2pz as a bonding molecular orbitals, and pi star 2py and pi star 2pz as anti-bonding molecular orbitals, when 2py and 2pz combine with the 2py and 2pz atomic orbitals of the another atom. Similarly, when 2px combine with the 2px of the another atom, it will give rise to the sigma 2px and sigma star 2px and bonding and anti-bonding molecular orbitals. As I said, there is interaction between 2s and 2p orbitals of the atoms. The interaction takes place because the energy gap between the 2s and 2p orbital is not very large, and therefore there is a interaction takes place, which can be shown like this. And due to this interaction, the energies, molecular orbital energy levels, these are changed. So sigma 1s less than sigma star 1s less than sigma 2s less than sigma star 2s. Here it was sigma 2px. Instead of that, it is sigma star 2s is less than pi 2py is equal to pi 2pz less than sigma 2px less than pi star 2py is equal to pi star 2pz less than sigma star 2px. So in this way, the energy electronic configuration sequence has been changed for B2, C2 and N2 molecules because the energy gap between these 2s and 2p orbital is less. Let us consider the formation of Li2 molecule and its molecular orbital energy level diagram. This molecule is formed by the combination of two lithium atoms. Each lithium atom has electronic configuration 1s2, 2s1. The 1s orbital is lower energy orbital, so it does not take part in the chemical bonding. Thus, 1s orbital remain as a non-bonding orbital. Only 2s orbital with its one electron in atomic orbital takes part in bonding. Since there are two atomic orbitals, they will form two molecular orbitals, that is sigma 2s and sigma star 2s molecular orbitals. There are two electrons which enter into the sigma bonding molecular orbital, that is sigma 2s. While writing the molecular orbital electron configuration of Li2 molecule, the presence of non-bonding 1s2 electron is shown by capital letter K because these two electrons are present in the first cell, that is K cell. There are two Li atoms taking part in bonding, so the letter K is repeated twice and the remaining two electrons of the Li2 molecule go to the bonding molecular orbital. The molecular orbital electron configuration of Li2 molecule is written as Kk into bracket sigma 2s 2. Let us consider the molecular orbital energy level diagram for Li2 molecule. This is an energy axis. This is a 2s orbital of lithium. This is the 2s orbital of second lithium. Both lithium atoms will have one electron each. When 2s orbital of first lithium atom combine with the 2s orbital of the second lithium atom, they give rise to the two molecular orbitals, one bonding molecular orbital and second antibonding orbital. Both lithium shares its electron in the molecular orbital, so the both electrons they enter into the sigma 2s bonding molecular orbital and there are no electrons in sigma star 2s antibonding molecular orbital. Let us calculate the bond energy and bond order for Li2 molecule. The stabilization energy evolved during the formation of Li2 molecule can be given by the formula energy evolved E is equal to number of electrons in bonding molecular orbital into minus beta plus number of electrons in antibonding molecular orbital into plus beta, that is equal to 2 into minus beta plus 0 into plus beta, that is equal to minus 2b. The energy evolved, that is the stabilization energy, is minus 2b, so the molecule is stable. Bond order BO is equal to 1/2 number of electrons in bonding molecular orbital minus number of electrons in antibonding molecular orbital, that is equal to 1/2 2 minus 0, that is equal to 1. The molecule is stable. The bond order is 1 and the bond energy is 25 kilocalories per mole. Since the Li2 molecule has all the electrons paired, it is diamagnetic and the molecule exists in the vapor state. Let us compare H2 molecule and Li2 molecule. H2 molecule bond length is 0.74 angstrom. Li2 molecule bond length is 2.67 angstrom. Bond energy is 103 kilocalories per mole and bond energy in Li2 molecule is 25 kilocalories per mole. The bond energy of Li2 molecule is less than H2 molecule because 2s and 2p orbitals of Li atom are much larger and more diffuse than in 1s orbital of hydrogen. They, they tend to overlap less effectively and at a greater internuclear distance than in case of 1s orbital of hydrogen. The 1s electron of Li cause repulsion between the atoms, which loosens the closer approach of the atoms. Due to above two reasons, the bond length in Li2 molecule is more than that in H2 molecule, and the bond energy in Li2 molecule is less than that in H2 molecule. Let us consider the formation of Be2 molecule and its molecular orbital energy level diagram. This molecule is formed by the combination of two beryllium atoms. Each beryllium atom has electronic configuration 1s2, 2s2. 1s orbital is lower energy orbital, therefore it does not take in part in the bonding. Only 2s orbital take part in the bonding, and they will give rise to the two molecular orbitals sigma 2s and sigma star 2s. Let us consider the energy molecular orbital energy level diagram. So this is the energy axis. This is the 2s atomic orbital of first beryllium. This is the second atomic orbital of the second beryllium. Both beryllium contains 2 electrons in their atomic orbitals. The combination of 2s atomic orbitals will give rise to the molecular orbitals. Each beryllium contribute 1 electron to bonding molecular orbital, that is sigma 2s bonding molecular orbital, and each beryllium contribute 1 electron to the antibonding molecular orbital, that is sigma star 2s antibonding molecular orbitals. Hence, in beryllium molecule, there are 2 electrons in the bonding molecular orbital and 2 electrons in the antibonding molecular orbital. The molecular orbital electronic configuration of Be2 molecule in the presence of non-bonding 1s2 electron is shown by the capital letter K because these 2 electrons are present in the first cell, that is K cell. The molecular orbital electron configuration of Be2 molecule is written as Kk sigma 2s2 sigma star 2s2. The energy evolved is equal to number of electrons in bonding molecular orbital into minus beta plus number of electrons in antibonding molecular orbital into plus beta, that is equal to 2 into minus b plus 2 into plus b, that is equal to 0. The bond order of this molecule can be given by the formula bond order BO is equal to 1/2 number of electrons in BMO minus number of electrons in ABMO, that is equal to 1/2 into bracket 2 minus 2, that is equal to 0. Since bonding energy as well as bond order both are 0, Bu2 molecule is not stable. Hence, Bu2 molecule does not exist in nature.